In this video, we're going to talk about simple and compound interest. Most people have dealt with this before at some point in their math career, but just to review, interest is money that is either earned or charged based on whether or not you're talking about investing money or borrowing money. So it's a way for whoever is loaning out the money to make money, all right, for loaning that money, for taking a chance and loaning money to somebody. Okay, so simple interest is interest that is earned only on the original amount. So, like in this example, if you invest $500 and you earn 6% interest every year for 5 years, and we're assuming it's simple interest, that would mean that you would earn interest on the $500. So, I would calculate that by doing 0.06 times 500. And if you plug that in your calculator, and I recommend grabbing your calculator, that will give you 30. So you're going to earn $30 and that'll give you a balance of 530. So we're assuming that you're investing into some sort of an account. And so you'll have $530 at the end of year one. All right. So the next year, you're going to earn $30 again because you're only earning the interest that was on the very first initial balance of $500. So I earn $30 again, and that gives me 560. I earn $30 again, and that gives me 590, 30 again, 620, and one more time would give me 650. Okay, so at the end of 5 years, I'd have $650. I'd earned $150 worth of interest. Not bad. Okay, not bad. Okay, but if I don't necessarily want to calculate it out like this, like if I wanted to figure out how much would be in the account in 25 years, right? I don't want to keep adding 30. So there's a formula, and the formula is this. A equals P times 1 plus RT. And some of us might have seen this terminology before. A is like the amount of it that we're going to have in the account. Okay. P is the principal. It's what we are either loaning or investing. R is our rate of percent, and T is time. All right. So that is simple interest here. I'm going to label that because I am going to put a second formula when we talk about compound interest. So compound interest is interest that's earned on the original amount and any interest added into the account. So instead of just adding $30 every year, you're going to actually recalculate the interest at the end of the year. So first year is going to be exactly the same. You're going to take your 0.06 times it by 500, and that's going to give you 30. So you'll have $30 in interest and you'll have $530 at the end of the year. All right. But now we're going to calculate the interest on $530. So we're taking that interest that was earned, and that's what we're going to calculate the interest on. So that's going to come out to 31.8, which I can think of as dollars would be 31.80, right? $31.80. So adding it, we'll get $561.80. So year 3, we're going to calculate the interest earned on 561.80. And that comes out to 33.708, which I'm not going to write because I want to do it in cents. So I'm going to round that to 3371 because you'd round it up. So 3371 added to 561.80. Plugging it in my calculator, I get 595.51 at the end of year 3. So comparing to our simple interest, we're like $5 ahead. So we've earned $5 more using compound interest. All right. So now taking 595.51 and calculating that, I'm getting 35. Here, I'm just going to go ahead and round it to the nearest cent. So 35.73. Technically, I got 35.7306, but 35.73, which I'm going to add to the 595.51. And that's going to be 631. Sorry, 0.24. I entered something in wrong and had to re-enter that. Okay, there we go. All right, so now I'm going to calculate the interest on that. And we are starting to see a difference, right? Now we've earned on year 4, $5.73 more, but technically we've been earning a little bit more every year. So overall, we're earning, a little bit more than we would have with our initial investment of simple interest. So 631.24, timesing that by 0.06, and I am getting 37.87. All right. So now we're starting to see some much bigger numbers. Adding that to 631.24 gives me 669.11. And there you go. So with compound interest, you are going to earn more. Now, at these kind of small amounts, we're not really earning that much more, at least not initially. But when you're talking about thousands of dollars, like people who invest money into new businesses, that's going to earn a lot more interest if you invest a lot of money. All right. But it's a risk, because if the business fails, then you're probably not going to get your money. Okay, so let's use our formulas to calculate these interests. So we did it using the tables for the first couple, but now let's do it using those formulas. Oh, sorry, let me give the formula. I forgot. For compound interest. So for compound interest, that formula, so let's scroll back up, is A equals P times 1 plus R over N to the NT. So N is something new. I'll tell you what that is. All right. N is the times per year that we are compounding. So we didn't have to think about that in our first problem that we were just doing, because we were just compounding it every year. So once a year. All right. But when you start looking at compounding interest like every month, that is going to then be a different number. We'd be compounding it 12 times a year. So this is the formula for compound interest. Let me write that in blue. So that's compound. That's simple. And I apologize that the screen keeps flashing. That's just because I have these tables and Word is mad at me for having tables. Okay, so let's do the simple interest formula. I'm going to write it down again. So A equals P times 1 plus RT. All right, so I'm going to plug everything in. So we're doing this for 5 years, at the end of 5 years. So without going through adding it up 5 times, we're going to take P, which is our initial investment of $500. R is our interest of 0.06, and T is time, which is 5 years. So I'll put time symbol times 5. All right. So we're going to plug that into the calculator. And if you plug it in correctly, and you do want to use parentheses, otherwise calculate what's inside the parentheses first and then multiply by 500. You will get $650, which is what we got on our very first table. Yay, we're amazing. Okay, so now compounded yearly, we're going to use the other formula, the one with the N. I'll write it down. And in this case, N is 1 because we're compounding it 1 time a year, yearly, 1 time a year. Annually, by the way, is another way of saying that, compounding annually. Okay, so 500 for P, 0.06 for R, N is 1, which kind of means it's a little bit boring. And then we're gonna have 1 times 5. All right, now quick piece of advice, especially for people who aren't really calculator savvy. Don't enter it, or I should say, don't enter the exponent as a multiplication. Some calculators can be a little bit annoying. So it's smarter to go ahead and simplify the exponent before you even enter this in. I'm just going to go ahead and write 0.06, since 0.06 over 1 is just 0.06. And then 1 times 5 is 5. So enter this into the calculator. It's much easier to enter into your calculator. If you struggle with entering things into the calculator, like you're not getting the same answers, please reach out to me. I have office hours. I can help you. You can send me a picture of your calculator and I can tell you how to enter things in. I love answering these questions and I would be more than happy to do that. So I'm getting 669.1127888 repeating, but I'm just going to round that to $669.11, which is what we got. So again, yay, we're amazing. Okay, so we're going to use that same formula, the compound formula, but this time for quarterly. So quarterly means 4 times a year. So in this case, n is going to be 4. So 4 times a year, they're going to add in the interest 4 times a year. All right. So I'm not going to rewrite the formula. I'll just look at the green formula I have written there. So it's going to be 500 times 1 plus 0.06 here. Actually, I'm going to give myself a little bit more space just because seeing what I have written above, I kind of ran out of room. So 500, 1 plus 0.06 divided by 4 to the 4 times 5. Okay, so there's nothing wrong with entering the division into the calculator. Even those who aren't super calculator savvy, if you just write 0.06 and then the division symbol 4 and then raise it to the 20, okay, everybody has an exponent button. If you don't know where your exponent button is, send me a picture of your calculator and I will tell you. Go ahead and enter that into your calculator. If you want, you could go ahead and divide the 0.06 by 4 and use a decimal, but that is a little bit dangerous later on when we start working with bigger numbers. So it's smart to just go ahead and only simplify the exponent. So just making that a 20 will make your life a little bit easier when plugging into the calculator. Okay, so I am getting $673.43 if I'm rounding it to the nearest cent. A little bit more, not a bunch though, not a bunch. And you don't expect it to be a ton more when compounding quarterly versus yearly, because it's not like you've had a lot of time to earn much interest in 3 months, you know? Okay, so compounded monthly. This is probably the most common compound interest. I mentioned it earlier, like credit cards or mortgages use compounding monthly. So in this case, n is going to be 12. They're going to accumulate or add in the interest every month. So we'll plug it in. And of course, I'm sure you're getting the hang of this. You don't have to necessarily write it all out, but I want to have it all written nice and neat so you see what it is I'm going to plug into the calculator. Okay, divided by 12, all raised to the 60. That's 12 times 5 is 60. Okay, so go ahead and plug that into your calculator. Oh, they did mention, by the way, you're supposed to write out the inputs, right? The formula used and the inputs. So in order to get credit on a problem like this, like if this was on an exam, you would actually need to write it out. Just plugging into the calculator and giving me the answer isn't going to cut it in this case. All right. 0.06 divided by 12, and then that's raised to the 60. All right, so I am getting $674.43. So again, even less of a difference, even smaller. Okay, that makes sense. That makes sense because we're not giving a lot of time to earn interest. All right, daily. Now we're going to assume daily is 365. That isn't always the case, like especially with accounting. So if you've taken an accounting class, they might do that a little different. We're going to just do 365 just to make it easy in case people haven't taken accounting. We're not going to go into that. So we're going to do this. Now, this one is the most important to go ahead and leave the division of 0.06 divided by 365. Otherwise, if you try to plug it in without that, it becomes quite messy. You'll get a very different answer. So I'm going to definitely write the division, 365. Okay. And then 365 times 5 is 1825. So this is what I'm going to plug in the calculator. 500 times 1 plus 0.06 divided by 365 raised to the 1825. And I am getting $674.91. It's like an even smaller difference, not even 50 cents difference from the monthly. Okay, but it is a tiny bit more, just not that much. And interestingly, that's not where it matters the most. It's yearly where it matters. How many years you let something sit, that's when the interest starts to really grow. Okay. But yeah, interest, when you're talking about how often it's getting compounded, it's not a huge difference. The big difference is between simple and compound interest in general. That's the biggest difference. All right. What, $19 difference, almost 20 bucks. Okay. So it is possible to compound an infinite number of times. I know that sounds a little crazy, but we're actually able to do that using a little calculus. You don't need to know why it works. You just can believe it works. And it has actually a really pretty formula. The formula is A equals P E to the RT. Now this is E, which is a number. So it's a special number like pi. So note E is a number. And here I'm going to put like pi. So it's an irrational number and it is on your calculator. If you have a scientific calculator, it's there. Just look for e to the x or something like that is usually e to the x, e to the y, something along those lines. E to a box. It kind of depends on which type of calculator you got. But that's what you're going to look for, e to the x. Some calculators even just have e, like an e all by itself. You may have to hit the second or shift button to access it. But if you have it, I would go ahead and find e to the 1 just to see it. And it comes out to 2.718 approximately. Okay, so like let's use this formula for this problem. I didn't ask for us to do it, but let's just do it. Let's use the same $500 investment. Oops, sorry. So that's P, E, and then R is 0.06 times 5 years. Okay, so in the calculator, I'm going to do 500 E to the, okay, so 0.06 times 5 is 0.3. So I'm going to find E to the 0.3. That's the easiest thing to do. E to the 0.3 first, which gives me 1.3498, blah, 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 blah. And then I'm going to times that by 500, and that gives me $674.93. So it's barely different from the daily compounding, just a tiny bit different. An infinite number of times calculating the interest, and it makes a 2 cents difference. So compounding continuously is an interesting concept. It's more theoretical, and it's used a lot in calculus. Okay. Effective rate is the corresponding rate if compounded yearly comparing to different compounding options. We're not going to do anything with effective rate. It's just kind of knowledge, just so you know. The idea with effective rate is that if you are comparing compoundings, that's what you would do. And we'll go ahead and on the next video, I'll show you how to do spreadsheets with compound interest.